All right, everyone. Welcome to Stats 101. This is a course where we introduce statistics in medical literature. And as we have informed you in the welcome email, this is not a course that's going to go into too much detail on the medical statistics. So we're not going to go into why methods are the way they are in too much detail. We're going to provide you enough for you to understand the concepts that we're going to teach. This course is going to take place over November and December, and it will be during the weekends over the next 2 months, right? So on Saturdays and Sundays, that's when the course is going to take place. The lectures will be on Saturdays like this, and we will also have an hour session on Saturdays, and you will have found the information about the labs on your calendars, and we'll also share it in a bit. Then we'll have SPSS on Sundays. The way the course is structured, we expect that you will attend the lectures, which are live and weekly, but we expect that you will choose one of SPSS or R, or whichever one you feel most comfortable with, or whichever one you would like to develop in. There's no expectation for you to attend both SPSS and R, so you have a choice. And to the extent possible, we will provide materials for you to develop in each of these software. And I'll make a little bit of a case as we go along as to why you should choose which one. At the end of November, if you want to drop the class, and I would ask that you stick with the class until the end of November and then decide if you want to keep going or not. And if you want to keep going on, if you don't want to keep going at that point in time, do reach out and we can, because at that point in time, we would have introduced the bulk of some of the introductory concepts, right? So chi-square, t-test, so you will have benefited substantially still, okay? But at the end, the course is going to finally end in December, and that's when we'll issue completion certificates for everybody. We have a large and diverse group of participants from all over the world. Welcome all of you. But also in terms of the characteristics of the participants, as you can see, there's a vast there's a substantial variation in the level of training of people, but also in what kind of training people have had in the past, right? So the bulk of the participants are health workers, medical doctors, medical students, residents, but we also have a substantial number of people who are coming from other subject matter subject matters as well. So public health. We have some people who are math, statistics, or epidemiology majors, and it's excellent to have people who might already have a lot of familiarity with the concept in the class, so they can help everyone else as we go along. So wide variety. We also have some social scientists in the class. I see some people who have studied economics, some people who are outside in public health, but maybe environmental health. So welcome to all of you. The schedule of the class, so this is an introductory statistics class, so ideally a very first statistics class that you will encounter. You might have come across all of these concepts before. I expect that you have, right? So we'll go through measures of central tendency, measures of spread, what's the mean, median, range, and the like. And then we'll talk about how do you compare them, right? In the third class. And then we'll look at comparing proportions and odds, and then talk about inference, okay? And then the class is going to change gears a little bit and go into regression methods. So linear regression, logistic regression, and then we'll also talk about survival analysis, comparing rates, Cox proportional hazards models. So this is going to be, 9 to 10 weeks of classes, and we'll have a review in the middle, and then we'll have a review at the end as well. We will have an SPSS schedule. Every week there will be a session for SPSS that will closely mirror the session that you would have had. So on Saturday, you will have the lecture on Saturday, and then on the Sunday there will be the SPSS, same time on Sunday, right? And with the goal is that we will take the SPSS as slowly as possible, so that anyone who actually goes through SPSS sessions throughout for this course will have a good enough understanding of how to implement all the methods in SPSS, and will have had practice. So the live sessions for the labs, we expect that as many of you as possible be willing to practice along, be willing to share your screen. So you should download SPSS ahead, right? And maybe get access to SPSS if you want to learn SPSS. Download and get started, and we will go through week on week SPSS along with the material for the lectures. Okay. And then we'll have the lab schedule for R. So the way R is structured is the subsequent week. So if we have had an R session, if we've had a lecture for that week, then the next Saturday, before the next Saturday's class, we will have the R. So R is going to be earlier in the day, so maybe more like midday, mid-afternoon, while the class itself is going to be later in the day. This is West Africa time. And I know that we're coming from all over the world, so please, on your own, figure out how this schedule actually works for your own time zone. And maybe and the calendar should help you in this case. So we have send out calendar invites to help you track on your own. But the R sessions, as I was mentioning, we have also shared in the welcome email, how do you download R, right? So introduction to R in terms of the sequence of the topics. We'll first of all introduce R, and then we'll talk about how do you make quantitative summaries before we then start talking about the statistics, comparing means and medians and the like. And yeah, so that's R. We will also have homework, and we expect to have 4 homeworks in the course of this course. And these homeworks, they will be just like the baseline assessment that you have completed. And those homeworks will also, so we will grade them and share comments as quickly as we can. You should please bear in mind that this is a huge class, 500 people, and there's a small teaching group, right? So please bear with us as we try to manage the class. So, and on that note, I want you to also, bear in mind that this is a large class. For yourself, make sure that you're turning off your mics, because if all 500 of us who are in this class leave our mics on, nobody can hear anything. Okay, so if you're taking a call, make sure that you drop off the class and rejoin, as opposed to trying to stay on the call because when the call comes through and you pick it, we're all going to be unable to do anything until you finish your call. So please bear that in mind as you join the class. So keep your mics on mute. If you want to contribute, use the reaction buttons on the bottom of the Google Meet. You will find that the reaction buttons. You can raise your hands, you can do thumbs up, you can share emojis, but please, as much as possible, we'll also want you to engage as much as you can. We want you to answer questions. We want you to ask questions. We don't want you to leave the class with unanswered questions, right? We want you to ask as many questions as possible and to engage with the teacher, right? So make sure that when questions are asked of you, as many as possible volunteer to participate, because that's the only way that we all benefit from the session. But that's the only way that it actually continues to make sense to continue to put this effort in. Okay. So having said that about engagement, I also want to make a quick point about the AI partners that many of you have. So I have seen people come on with Otter, OTTER. I have seen people come on with Note Taker and all these other apps that you have. We ask that you kindly disable them for these classes, right? We will record the class and we will share a Gemini a Gemini script, or Gemini will take notes on our behalf and share with you. But if so many people are sharing their note taker app and having that send all of us email, and having, first of all, it's hard to know who is in the class when maybe there's 200 people, but half of them are AI, then that's really difficult for the teacher. So please, we ask that you disable them or exclude them from these classes. Okay. Um, these are the people who are going to be teaching the sessions. So it's myself, Dr. Igor Sage, Dr. Motayo. And as you can see, this is a group of people, many of them PhDs, epidemiologists, statisticians, who have who are dedicating their time to volunteer with StatsClinic. And we ask that you bear this in mind as you join. Please note that we're not doing this because we have absolutely nothing to do. These are all very busy people who are making the time. This is the leadership of StatsClinic, and this is the leadership of StatsClinic. And if you have questions, please do reach out to any of us. Aura is leading operations for us, and she's going to be on all the classes. And if you have any concerns, she will likely be the one to address them on your behalf. I want to talk about statistical software, but I want to take a break and come on so that I can see the reactions and see the Google Meets, and ask if anyone has any questions at this point before I keep going. Any questions? No questions. Perfectly understood. Okay. All right. So I want to talk about, so I see Mary. Mary, please ask your question.
All right, thank you so much, Dr.
Yeah.
Ibrahim. My question is really simple. I just wanted to ask for about accountability. Is there going to be like a WhatsApp group or somewhere that we can ask questions after assignments have been given, and we need like further clarity on how to reach out to the instructors? Are there like is there a way provided that we can reach out, or we just come to the class and then during the live sessions we can then ask the person that is taking the instructor that is taking? Thank you.
Thank you. Good question. So you can ask questions during the live sessions. There is also Google Classroom. If you have not joined, please join or ask questions about how you can join. Um, Google Classroom has a stream where you can ask questions of people in the class who are participants. You can also ask questions of instructors. So that's two ways, so Google Classroom and live sessions. But you can also email StatsClinic if you have other questions that are related to operational, or if you're trying to get in touch with one of the instructors. We had shared a link for office hours, but disabled it. Um, but that link for office hours, when you email and you can email to ask to schedule some time, and then we will set up a time with you to meet at the earliest possible opportunity. The reason why we disabled it is, so even before the class started, I started getting questions, and my sense is that maybe people come schedule these meetings and they don't show up. There's not a lot of understanding of how these office hours work. So if you need to speak with one of the instructors, please reach out and send an email. Okay. Hafsat is next.
Hello. Thank you very much, sir, for taking the time to teach us the Stats Clinic 101. I just have one question. I have a friend that applied, and she didn't get the email to join the Google Classroom and the schedule. I was wondering if it's okay if I could share the link with her so that she could join the class. Thank you.
So yeah, thank you very much for that question. I would rather you do not. So the thing is that we can only take the maximum number of participants we can take is 500, right? So obviously not everyone is going to be able to join all the sessions, but our commitment is that you should be able to join. We don't want a scenario where on the days that everyone is trying to join, um, that they're not able to get on. So the maximum possible participants for class is 500. And for everybody that's in this class, there's maybe one more person who did not get in. Okay. So there are many people who did not get in. It's not just your friend. We weren't able to allow everybody who applied, unfortunately. Um, so this is one of the unfortunate realities. We have a YouTube where we have a lot of the recorded classes actually are already on YouTube, but then they will not be able to participate in the live sessions that we have. But it's just the way it is. When the resources are scarce, we have to distribute them in some way and come up with some rules about who gets in and who does not, unfortunately. Okay, Mohammed.
All right, thanks so much, Dr. Ibrahim. Although the question I'm about to ask, I'm not sure if it has been answered because I joined, I think, 10 minutes after the class has been started. So my question is, I don't know if I misunderstood the email that you can join the R class and the following week you can join the SPSS class. I want to ask, is it optional if you've joined one, you don't have to join the other, like R and SPSS, or you have to join the both? So I want to make the clarification. Thank you,
Good
sir.
question. Yeah, I did talk about it briefly. It's optional which one you join, and it's completely up to you which one you join. You don't have to join both. Okay, thanks. Yeah. All right. Hafsat,
Okay, thank you very much. Good evening. Okay, my question is, I got the information, I got the meeting through my mail, but I wanted to ask that is aside from mail, that is there a WhatsApp community where informations can spread easily, or maybe like updates, or when it comes to documents being sent, or this timetable schedule, for instance, could be sent aside from the mail.
thank you very much. We have avoided WhatsApp groups, partly. I mean, yeah, we have avoided WhatsApp groups in general. They require a different set of resourcing to manage and the like. So we have not created WhatsApp groups in the past. We have not created them for this class. Um, so that's the information that I have on that for now, unfortunately. Yeah. Okay. Thank you very much. I see two more hands. I think I already answered Afsat's question. So Abarami. Abarami, have your hands up.
Hello.
Hi.
Thank you. Thank you, Dr. Ibrahim. I just want to ask that what of if one is interested in joining both the R lab and the SPSS? Can we all do that?
You can do that. Yes, absolutely.
All right. Thank you.
Yeah.
Thank you.
Okay. All right. Thank you very much. So I was going to talk a little bit about R and SPSS, and to just for people who are struggling with making a decision about which one to join, right? So let me talk about SPSS quickly. SPSS is a statistical software, point and click, right? So the way, if you're comfortable using Microsoft Word or Excel, like you know how to click and move around, and you can use basic computer skills, you should be able to use SPSS. Now, unfortunately, SPSS is not free, right? And although you can download the trial version online, um, unless you have a way of getting SPSS, then it'll be a struggle, and StatsClinic is unable to provide SPSS access. So that's the thing. The key concern for SPSS is one, the fact that it's not free. But there's a second key concern for SPSS, and that is reproducibility. When we conduct analysis in R in statistics, we want you to be able to reproduce the analysis in the exact same sequence in an easy fashion. And you will see if you take R, why R is reproducible. With R, if you conduct if you write code for an analysis today, 20 years from now, if you run the same code, you'll get the same exact results, right? But with SPSS, you will have to click through again, unless you use the SPSS code, which most people don't know how to do, and we're not teaching that. But reproducibility is a key challenge with point and click interfaces. So that's the thing. But for R is code based. So that means that if you are not comfortable learning the code, right, then it's going to be a challenge for you. I mean, the code for R is accessible on the internet. If you're trying to do, if you know what you're trying to do and you send and you Google, you should be able to find it. But the question is usually getting started in the first place. And those are some of the things that we're going to be able to teach you. And so that's why ultimately the focus of this class is both on teaching you what you need to do in terms of the concept, but also in how you're going to implement it in terms of the software. And you have a choice of either SPSS or R. Okay, all right. So I'm going to stop here and hand over to the instructor for the day. I don't see her on. Any questions in the meantime while I... Okay, so real one, please ask your question.
Okay, sir. It's still on the Google Classroom. Even me, I don't have access to the Google Classroom. So my question is still, later, are you going to add the others, or is it going to be, sir?
The Google Classroom. So Google Classroom, thank you. So we send a link for you to join Google Classroom in your mails. So please check your mail. If you're having trouble joining Google Classroom, please reach out to us. Otherwise, if you check the email, the welcome email that you got, it has information about Google Classroom and how you should join. Timothy?
All right, thank you very much. Good evening. I just wanted to clarify for R. You mentioned that, yeah, of course, I know SPSS software is paid. You can only use the free version for a limited period. So I want to know about R as well. Is the software free, or do we have to also pay for that?
I did not mention that. Thank you very much. Very good question. So the software for R is free. Okay, so R is free. Yeah, exactly. So SPSS offers a 14-day trial. R is free. Somebody also asked if we offer CPD points. We don't, unfortunately. It requires its own administrative overhead and all that, and StatsClinic is not equipped to do that at this point in time. We're a small, nimble organization trying to focus on our mission of actually teaching the methods. Okay, all right. Biruk?
Thank you very much, Dr. Ibrahim. I know you've mentioned it, but I just wanted to clarify. The sessions will be recorded, and you'll be sharing them through the classrooms, or is it somewhere else?
We'll share them through the classrooms. Very good question. Yes, thank you.
Okay. Is being present in live sessions a requirement, or?
It is not a requirement, but it is highly encouraged. I mean, I know that we are busy adults, busy people. We have different things, schedules going on. Being present in the live sessions is going to make your life easier. You can ask questions in real time, but it is not a requirement. Nobody's going to be chasing anybody down. Okay. We already have recorded sessions for all of the material we're going to teach. So if you go on Google Classroom, for today's class is already pre-recorded. Okay. And every week we're going to release the additional recordings and the material, the slides. We'll share that ahead. Okay. So yeah, so we will, but in addition to that, we'll record the live session. So if you want something that's particularly the iteration that you missed, right? So maybe the professor said something in the class, would like to hear it again, and that's going to be on. Okay, all right. So this has been 30 minutes of introducing the class. I know that you have a lot of questions that are unanswered. I will now switch gears Um, all right, so I think let's take a 3-minute break and then come back. And when we come back from the break, we can get started with the class. Okay. Thank you very much. See you in 3 minutes. Hi everyone, sorry, please bear with us. We're experiencing some unforeseen challenges, but the instructor is going to be able to start now. We're just switching. Apologies.
Good evening, everyone. Can you hear me?
Yes, loud and clear.
Okay. Just a quick introduction. My name is Mohammed Yisa. I'm one of the instructors here at StatsClinic, and I'll be filling in as the backup instructor um, for this session. So just give me a second while I get the slides open. Does someone have their hand up? Sharing my screen now. Okay, please confirm that you can see the first page of the PowerPoint presentation.
Yes, we can.
Okay, and apologies for the technical issues. I think this just goes to buttress Dr. Abioye's point about the class sizes and what it does to the platform. As you can see, we're using free tools to conduct the class. So because we've already taken a lot of time, I'll just go straight into the outline. For this class, the objective is to understand the importance of measures of central tendency, the types of variables that we use in statistics, what are those measures of central tendency, and how we display data in tables and in graphs. So there's this picture here, and then there's a scenario basically to get us thinking about central tendency using day-to-day scenarios. So let's say in a when you have groups of animals, a group of goats is called a trip, a group of whales is called a school, a group of fish actually is also called a school. And usually when you encounter things that can be counted in life, we like to group them so that we can better understand them. And usually, once something has been grouped, then there would be a need to understand what the typical representative of that group looks like. For example, you can ask what
is the typical launch, or what is the launch of a typical MPH student, for example. That is a form of average. So basically, a measure of central tendency is the simplest way to summarize and describe data. So if someone asks you a question and says, how tall are men in Ibadan? Then if you were to answer very literally, you would count the heights of each and every man in Ibadan, but that would take you centuries. So rather, you would give the person an average and say that on average, men in Ibadan are usually 5'8" give or take 2 inches. So that is the kind of thinking that we that goes into the measures of central tendency. And this is important to be able to convey data in a very quick manner, so that, for example, when you come to decision makers as a public health professional or as a health professional, and you are trying to, let's say you are trying to secure funds for the equipment of your wards in your hospital with BP measuring machines. And the head of the hospital asks you, how many do you need? So you would say on average in the hospital, we have, let's say 10 wards, and then on average, each ward needs 3, give or take 1. So that would help you and help the person approving the funds to ensure that you are planning properly. So just stop me if I tend to be going a bit fast, and I will slow down. So that being said, that brings us to the classic first topic whenever we are taking any stats class. Statistics. The currency of statistics is data, and we need to know what data is and how data can be described. So in health research, we encounter several different types of variables or different types of data. And these data can be either continuous, meaning that they can take on quantitative values that continues. That means it can take a decimal point. Things like blood pressure, birth weight, height, things like somebody's body mass index. These are all continuous variables, and they can be summarized using mean, median, or percentiles. Discrete variables are quantitative variables as well, but they take on specific values. So they are often referred to as counts. So for example, how many patients did you see in the clinic today? You cannot say you saw 1.5 patients. You cannot say you saw 1.5 patients, or that you saw 2.5 or 0.7 patients. So that is a discrete variable, also known as a count. Categorical variables are self-explanatory. Basically, these are variables that split a group into one or more categories. So it could be things like yes or no. It could be things like categorizing people based on their BMI into underweight, normal, overweight, or obese. It could be things like the classification of hypertension, where you say pre-hypertension, normal, stage 1, stage 2, or any other form of classification. These are all categorical variables. So I'm just checking if we are all on the same page so far. And please excuse the background noise. I have an assistant professor with me. So
when we come to categorical data, we have already understood that the categorical data splits data or splits a group into different classes or categories. However, these categories could also have some form of preference over each other. In that case, they are ordinal, or they could be um, categories that are not preferential in any way. They are just different, and in that case, they are nominal. So categorical and examples of nominal categorical variables include things like colors, things like sex, male or female, things like profession, things like marital status. These are all categorical variables, and one does not necessarily take any form of preference over the other. However, in our data analysis, we use numbers to represent them because that is the way that the computer understands it. So ordinal data, we said these are quantitatively ordered and ranked. So for example, if you are talking about a previous example that we gave, BMI, from underweight to normal to overweight to obese, these are, you could say, increasing orders of severity. Or for example, HIV, stage 1, stage 2, stage 3, stage 4. These are all also increasing orders of severity, which means that the categories actually are ranked above each other. So this is a learning check. Let's see who's going to be the fastest finger. So let's say you measured among 5,000 patients, you measured the systolic blood pressure, and you decided to group those systolic pressures into 4 categories. 1 is less than 90, 2 is between 90 and 120, 3 is between 120 and 130, and 4 is above 130. So looking at these categories, what type of variable is your new SBP variable? Fastest finger.
Ordinal
Yes?
categorical.
Sorry?
Is an ordinal categorical data.
Okay. Does anyone disagree? Okay, thank you for answering. Just to note that when we are presenting our screens, we can't really see the team meet interface. So I'm not able to tell when you are raising your hand except by the sound, and I'm not able to tell who is speaking. So just say your name before speaking. Thank you. So it's correct. It's ordinal categorical. So that is a brief introduction into the different types of data. We mentioned earlier that we use things like averages to summarize data. This is proportions is another way in which we summarize data and present it for dissemination in our publications and to stakeholders. So really, a proportion is when you divide one variable by another variable. So for example, if you divide the number of cases by the number of individuals in the study population, that is a proportion which is known as prevalence. So usually when you want to calculate a proportion, you really need to know what the numerator is, which is what you have measured, and the denominator, which is the total number of people in that population, or an estimate of the total number of people in that population from which the
observations were made. So, and because the numerator is actually a part or a portion of the denominator, the proportion would range from 0 to 1. So if you say on this class right now, this Google Meet meeting of 500 people, how many, what proportion of these attendees are attending on their phones, and you count that, then the numerator would be the number of people who are attending the meeting on their phones. The denominator would be the total number of people who have joined the meeting. So that gives you the prevalence of phone use to join StatsClinic and live sessions, if that makes sense. So that's so when you come to proportions, again, like I said, there's something called prevalence, and prevalence basically is what you have taken a snapshot of. So what I measured, what I depicted right now is the prevalence. How many people have the condition of interest at that particular given point in time? So usually this comes from when you do a cross-sectional study or a survey, then you get a prevalence. That is why sometimes cross-sectional studies are also referred to as prevalence studies. Now, when it comes to cumulative incidence, this is when you measure the number of new cases over a particular period of time. So let's say you carry out a study over 12 months, and then over those 12 months, you measure the number of new cases. Then in that scenario, you have measured the cumulative incidence. Is it clear so far? Well, I'll just listen for the beep and assume there are no questions if otherwise. So other ways of summarizing data is rate. So rate is a measure of occurrence of disease or occurrence of a condition of interest per unit time. So usually we use this in cohort studies. If you have participated or led a cohort study before, you would know that you would design it for each participant, let's say, to spend 12 months in the study. However, one, not all participants may end up starting in January and finishing in December. Two, not all participants may make it to the end of the study for one reason or the other. Some might travel and you become completely unreachable. Some might die, and some might just decide that they no longer want to be part of the study and sign out. So in order to get an actual representation of the time contributed by each participant in that study, then you calculate the incidence rate. So it is given as the number of new cases of a disease by per unit time. So let's say you have sorry, I'm having a bit of instability. Let me turn off my camera to make the network a bit more stable. Okay, so as I was saying, for the incidence rate, you use it to calculate the amount of time that each participant has contributed to the study, as well as the number of new cases during that time period. So the formula is given as the number of new cases during that time period over the total time spent in the study by the participant. So let's say you are doing your period of observation is 1 year, then it is expected under normal conditions that your 500 participants are going to contribute a total of 500 person years to the study. However, some participants, after maybe four months, decided to leave the study area, and they have not been able to we have not been able to follow them up. A couple of them died, and some withdrew their consent. So what we are going to do, let me see if I can get a pointer. So what we are going to do is that we are going to measure the amount of time spent in the study by each participant. Now, this participant C is representing 1 year. Let's say it represents 1 year. This symbol, a vertical line, represents a participant who has dropped out, and the point at which the participant has dropped out. X represents a participant that has died. So participant dropout is either withdrawal of consent or loss to follow-up. Now, you have some participants, let's say out of 500, 400 participants, or let's say 450 participants spend the whole year in the study. So those 450 participants have contributed 450 person years to the denominator. And then 25 dropped out at 6 months. So those 25 people have each contributed 0.5%. So that's 0.5 times 25 is 12.5. I hope I'm not confusing anyone so far. Let me see if there's a pen to write. No.
Please, can you go over it again?
Yes, okay. So I said that for incidence rates, we are calculating the number of new cases. That is very clear, right? We're just counting over the total amount of time spent in the study by the participants. So in an ideal world, if you are recruiting 500 participants and you want to follow them up over a period of 1 year, then this denominator would be 500 person years, because you multiply the number of participants by the amount of time spent by each participant. Does that make sense so far?
So yes, what is the unit of measuring participant time? Will it be in years as a unit, or it's in days or something? Yeah.
It depends on what you are using. So if you are doing it if you are considering months, then it would be months. If you are considering years, it will be years. Does that make sense?
Yes, sir.
Okay, so for this class of 500, let's say, let me use an easier example. We have 480 who have spent 12 months in the study. Then 10 have dropped out at 6 months because they withdrew consent, and 10 have traveled to the US and we are not able to reach them again. We are conducting the study in Africa. So it means that these 480 have each contributed 1 year. So we are going to multiply that 480 by 1, which is 480 person years. We put that on one side. and then add the contribution
May you please
from
share your
these
screen?
other groups. So, sorry, can you see it? Can you see my cursor moving?
Yes.
Okay. Apologies. I don't know why I'm not able to annotate. I would have. It's not giving me the option to write, but I can write this down and share it on Classroom after the lecture if it's not clear. Okay. So we have 20 people out of 500 who have contributed 6 months, which is half a year. So we are going to multiply that 20 by 0.5, which is 10, and then add it to the 480 who have actually contributed a year. So let's say for whatever condition, the top value is, let's say 30. In 1 year, we got 30 people who have what we are looking for. And then the amount of time contributed total after this calculation is 490. Then our incidence rate will be 30 divided by 490. Yes, unmute and speak, please.
Sorry, what about you said out of 500, 10 of them withdrew consent. Wouldn't
Yes.
it matter at what point they withdrew consent? Do we need to factor that into the total participant time as well?
Yes, if I did not mention it, I meant that they withdrew consent at 6 months. So I'm giving a very simplified example. Does that make sense?
Yes, it does.
Okay. So depending on the number of conditions that we're looking for. If, let's say, this first thing we calculated is I'm trying to give a very mild example. Let's say the number of people who had runny nose over that time period, then we'll say that we got 30 over 490 person years. And then we'll resolve it into its simplest form. Can somebody do 30 over 490 on the calculator? Let me see.
.06.
0.06. Okay, so that is 0.06. That's 0.06 cases of runny nose per person year. And if you want to make it a whole number, then you would do some reciprocal where you would, instead of saying, so you can see here we have a someone saying a case where there is 0.4 deaths per person year. But if you want to resolve it into a whole numbers, then you would basically divide both sides by 0.4. So one here you have 1 per person here, you have 1. You divide that 1 by 0.4, you get 2.5, and here you get 1. I really hope I'm not confusing anyone.
Okay, so
okay.
Per person year. Okay, so that's why it's 1.
Sorry?
You say per person year. So that's why it is 1.
Yes.
So that's 0.06 cases per person year in 1 person year.
Yes. But if you want to say 1 case of runny nose, then you would divide that 0.06 by itself, And then for the number of person years, you would divide 1 by 0.06. Then it will give you an expression like this, where the number of person years will be a fraction.
Okay, so that's okay.
Okay. Yes, unmute and speak. Okay. Going to the next slide. So, the next slide talks about, this slide talks about the 3 general types of analysis that we do in statistics, and the reason why we do them. So, it is possible that a lot of us are coming in with a lot with experience in doing statistical calculations and making inferences, and that is good. And for some, maybe like me when I was in undergraduate, I just understood that the most that I understood about statistics is that there's something called p-value, and if it's less than a certain number, we reject or accept hypothesis. So we are trying to simplify that, and that is why we have classified the types of analysis in statistics into 3 broad types. So one is to describe the population of sample, the population or the sample from which the analysis is being done. That is descriptive statistics. So that is where you talk about things like the highest, the maximum value, the minimum value, the mean, median, the range, and other types of summary statistics. To predict an outcome, which is regression, you might have heard a lot about regression. So prediction of an outcome, to say that what would be the risk of developing a stroke if the person stays over a systolic BP of 140 for this amount of years, or what is the risk of cancer for someone who has smoked 10 sticks of cigarettes for 30 years. Those are all things to do with prediction. And then machine learning and AI as well. So all the AI bots that you are using to take your notes, they all come from prediction, and machine learning that is being put to very good use these days, or in clinical practice. You know, there are AIs that would help you, that are helping clinicians to predict whether or not an X-ray is suggestive of tuberculosis, and whether or not a particular image is suggestive of cancer, and things like that. So they are being used to different degrees, and a lot of these, all of these have their foundation in predictive statistics, basically regression. Another reason why we do statistics is to clarify relationships between exposures and outcomes. And this is the huge chunk of what epidemiologists do. What is the relationship between exposures and outcome? For example, people, we have, those of us in the clinic would always tell women to breastfeed their children because it is protective to the mother and is protective to the child. To what extent is it protective to the mother or to the child? These are things that we these are things that we use causal inference to clarify. So there's a bit of an overlap between these two, the prediction and the causal inference, and that would be clarified in the relevant class. So we have talked about different types of variables. Now here is an example of a data set showing different types of variables. This variable, the first variable on the left here, says current institution. So let's say this variable is trying to tell whether you are currently registered at University of Toronto or University of Cape Town or Unilag or the University of the Gambia. So depending on what that value is, you'll be assigned a value 1, 2, 3, 4, 5, etc. So what kind of variable do we think this is? Can anyone guess?
Categorical nominal.
Categorical. Okay. Would that be ordinal?
Nominal.
Nominal. Okay.
Nominal.
Okay. And what about the age?
Continuous.
Continuous. Okay.
Discrete.
Because we can
So
be
it's
2.5 years
discrete.
old.
It can be discrete. Okay,
It's
okay.
discrete.
Depending on how we are looking at it, right? If we are using age at last birthday or completed years, age in completed years, it becomes discrete.
Okay. Sorry, just to remind us again, I'm really enjoying your interaction and your feedback. Can you say your name and then speak?
Okay, like I
So
told
my name is Abdul Karim. Age
okay,
it should be discrete.
Discrete. Okay.
Yes.
And who said it could be either discrete or continuous?
Yeah, that's Jerry. I'm saying that depending on how we want to look at the variable, there are some variables that have a cap that it should be age at last birthday or age in completed years. So in that case, if it's age in completed years, it would be a discrete variable. But if it's just open age and to take age and maybe months in progression, it's continuous.
Okay. So depending on whether you are rounding it, you are rounding the age to significant figures, basically. If you are not accepting any decimal points in your age variable, then it will be discrete. If you are accepting decimal points, it will be continuous. So this age distribution now is, we can see 25 to 30, 35 to 39, 30 to 34. So it looks like we have classified the age into different class bands. So what kind of variable would this be?
That would be a categorical ordinal. This is Victor speaking.
Okay. What about the sex?
Sex would be a categorical nominal.
Sex will be binary.
Binary. Okay. So you are both right.
Sex is binary.
It is. You are both correct. It is categorical and it is binary, and it is nominal as well, because it's not, one is not necessarily ranked above the other. Marital status, children. So children, this is number of children. So is this categorical? Is it nominal? Is it ordinal? Is it discrete? So I'm just going to, I'm not going to go through everything to the end. I think you all have got the gist of that initial classification of variables. And this is a point for you to maybe just look at it and on your own time, decide what kind of variable each one of these is. And that would really help. Understanding the type of data that you have would really help you, is really the foundation of any form of statistical analysis that you are going to perform. So talking about quantitative summaries. If you remember this talk, we are talking about how we summarize and present data. So for quantitative variables, we have these things called measures of central tendency. What does the average person in the group tend to do? And that was where we're talking about what is the height of men in Ibadan and all that. So there are two measures of central tendency for quantitative or
Hello, sir.
for quantitative. Sorry.
Yeah, sorry. I had some problem with my connection here. I just wanted to know if you are going to share some slides after maybe the presentation. I don't know. I have been
Yes,
trying to join the class, but I had some network connections.
No problem. So these slides would be available on the classroom as well as the recording of this session.
Okay, thank you very much.
Thank you. So as I was saying, in our health data analysis, we tend to use mean and median a lot. There are other types of measures of central tendency. There's the mode, which is the most commonly the one that occurs the most number of times. So what is the mean? When you have a list of numbers, simply you just divide the sum of all those numbers by the number of values. So let's say you are trying to find the mean age of a class of 10 students. You would, on the numerator, on the top here, you would add up all their ages, and then on the denominator, you just divide by 10, because that's the number of values in that population or in that sample. So that is the mean, and it's popularly called the average. So this is arithmetic mean. That's the mean that we use most commonly. And when it comes to median, you would have a list of numbers. Again, let's say you have 10 or let's say 15 students in a class. Then you would pick the value that is in the middle of the list if you organize them in ascending or descending order. So if we want to find the median age of that group, we would order their ages by from the lowest to the highest. So the youngest to the oldest, or from the oldest to the youngest, and then we choose the value in the middle. So usually that would be n plus 1 over 2. If you have, let's say you have an even number of, if you have an even number of observations, or rather an odd number of observations. So you would go to the middle observation, and that would be your median. So if you have a normal distribution, let's say all of your values are distributed like this, where most of the values are converging around the mean, and the bigger values are converging around the middle, and then you have the smaller values, the outliers, on both ends. If you distribute your data, plot your data, and it's looking like this normal distribution curve, then your mean and median would be more or less the same, because once you do the average division, and you also look for the middle number, they would both be the same. So that is for the what's it called, for a normal distribution. But if your distribution is not symmetrical, then we would choose a median as our measure of central tendency. Let's say this hill here is on this side, and you have a long tail to the right, or you have the bell on this side, and then the long tail is to the left, then that means that it is not normally distributed, and that the mean and the median would be so far apart that the mean will not really give you a true representation of the average in that data set. So for those kind of data, it's better to use the median rather than the mean. Okay, so this is just an example of how the median and the mean are related to each other depending on where the tail is facing. So if your tail is facing right, then the median would be larger than the mean, and vice versa. So when you have a lot of outliers in your data, your mean would not really would not be a fair representation of that data set. So the median would be a better representation. And you are taking this is an example now to demonstrate the differences between median and mean. So someone's hand is up. Can you unmute and
Yes,
speak, please?
sorry. You were breaking when you were explaining the bell shape for asymmetrical for data that is not normally distributed. And I missed you when you were talking about not the mean not being the best thing to take in. I lost that part.
Okay. So I said that in cases where you have a normally distributed data, the mean and the median would lie around the same place. If you cut this into two now, 100 is your median, because we said the median is the value at the middle, right? If you also should take the average and sum up all these observations and divide it by the number of observations, this x, your mean, is 100. So for a perfect normal distribution, the mean and the median are the same. And this begins to deviate to the extent that you have skewness in your data set. So if your data set is very skewed, like this slope that the athlete is skiing down, then your median would actually be a better representation of the complete data set rather than the mean, because the mean would not really give you a representation of some of the outliers that you have in your data. Does that make sense?
Yes, it does. Yes, it does.
Okay. So here we have an.
I have a question. Well, thank you very much
Yes,
for the presentation. I just want to find out, let's say you want to check the distribution of a paper, sorry, of a data, and you have,
Yes.
let's say, 3 continuous variables, the age, let's say height, and then another continuous variable. Do you need to check the distribution using these 3 continuous variables, or you can just focus on age alone?
Well, I'll answer that question, although we are going to do that in the statistics lab, in the SPSS and R labs. So if you are, it depends on the statistical test that you want to do. For some of them, they would say that each of the statistical tests have their rules that need to be satisfied. And some would say that at least one of the 2 things you are comparing needs to be normally distributed, and each test has its own rule. So we would discuss those rules as we come to them.
All right. Thank you very much.
Thank you. So I don't know how much time we have left. Ore, are you on the call? Can you please give me a time check?
Hi, yes, we have about 26 minutes left.
Okay, so I'm going to try to breeze through. Kindly keep your questions to the end, and I'll try to answer them. So here, taking an example of mean, we have a data set of 10 ages. These are 10 young resident doctors. You can see that the oldest is 38. So they are not, if we want to take the mean of these 10 resident doctors, all we have to do is to add them up and divide by 10. And the mean here gives us 32.1. And the median is 31 for this data set. So you can see that the data is reasonably used, that this data is normally distributed. So and that is the reason why the mean and median are kind of almost the same. If we were to change only one value, just one value that is an outlier, which this last value here, we're changing it to 51. It means that only, which is a huge change from 32.1, but the median itself does not change. So it means that if you are looking for a measure of central tendency that would really be resilient to outliers, because like the name implies, if you look at the tail and everything, the outliers do not represent the biggest chunk of the data set, then your median would be a better option, because that gives you what the actual central figure is for that data set. Someone has their hand up. Okay, so I'll proceed if there's no question. So this is a second check. Let's say you have recorded the height of the kids who have been attended to at the pediatric clinic every day for this week, and then you plot the histogram for day one. The histogram indicates that the data may be normally distributed. Which average would you use?
Mean.
Mean. Okay. Does anyone think it's median?
I think I can use
Yes,
both.
I think it's median.
Okay, why do you think it's median?
Yes, I think it's median because with a normal distribution and a bell-shaped curve, the mean is the median itself. So we can both use mean and median. The median is the mean, so the mean equals the median. If I can remember correctly.
Yeah, you are right about the mean and the median being almost the same in a normal distribution. However, in our calculations, when we have a normal distribution, we tend to use means. There are several different reasons for that, including the fact that you would be able to really get the contribution of each and every member of that data set by adding them up and dividing it by the number of observations. But when it has outliers where you have massively big numbers or massively small numbers that are out of the very way out of range of what the data looks like, giving you a skewed tail, then your median would be the preferred measure of central tendency. So in very simple terms, if you have normally distributed data, use the mean. If it is skewed, use the median. The theory would be explained in further lectures as well.
Thank you very much for the correction.
Sorry, if we are to talk about the previous histogram, I'm seeing
Yes.
that the tallest bar is on 100. What actually is it? Is that tallest bar? Is it telling us that majority of the children are around 12 years?
12.5. 12.5. This is height. So I'm not quite sure what the unit of measurement here is, because it can't be meters. I guess this is it's a hypothetical. Okay, so let's see.
Yeah.
Okay, so this is the number of observations on the left, the frequency, right? And then here on the x-axis, you actually have the height. So these are the heights. The shortest person in this data set is 80 centimeters, and then the tallest is 120 centimeters, which is 1.2 meters. Then these are the number of observations for each of these heights. Does that make sense?
Yes, well, I was just looking at how do we get 12.5. If you look at that height there, if there are a number of observations, that is a continuous data. So how did they measure the 5? So that's where I was confused.
So I get what you mean, but this is 12.5 here, but you can see that nothing is touching that 12.5. So the number of observations here is actually probably 12 if this were to be graduated without decimals. Similarly, this would be 8 and this would be 7. Does that make sense?
Yes, it does. Yes, it does.
So on this, in a different study, you have done the same thing. You have measured the heights of children, and it gave you this histogram. So would you say that this histogram is normally distributed or not?
No, it's skewed. It's skewed to the left.
Okay. Okay. And what measure of central tendency would you want to use in this situation?
We use the median.
The median.
The median.
Median. Okay.
Median.
So I hope everyone is following the lecture. So, like I mentioned earlier, the mode refers to the most commonly occurring set of numbers, which means that let's go back to that example. In this example now, where you have a set of 10 resident doctors, if you count the ages of the resident doctors, you see that 31 occurs here 1, 2, 3 times. 29 occurs 1, 2 times. And each other number occurs once. So 31 being the highest, the number with the highest frequency is the mode. So that's what the mode is. So when you have normally distributed data, then the measures of central tendency are going to be the same. The mean is going to be the same as the median, and this is going to be the same as the mode. That's just one of the fascinating things about normal distribution. So sometimes in a data set, you might have more than one mode. You can see that these two ages of onset are really competing with each other to be the mode. And in this case, this is described as a bimodal data set. So this particular histogram is for the age of onset of narcolepsy, which is a condition where people find it difficult to stay awake in the daytime. And it has two ages of peak onset. Here, I think this is around the ages of 14 to 15, and here is around the ages of, let's say, 34 to 35. So this would give you a better picture when you are trying to inform policy, if you are trying to inform the evidence-based practice for whatever field in which you are practicing. So this line alone might give you the impression, because it is level as in the normal distribution that we showed. This one is also level like a bell curve. At first glance, if you are only looking at this, you would think that the data is normally distributed. But you can see clearly on the histogram, there are two areas where it peaks, and this is a bimodal data set, and it actually gives you very important clinical information as in this case. So another way in which we summarize data, we use frequency tables. This is one way in which we have summarized the data on a histogram. We have summarized it previously using the measures of central tendency, the mean, median, and mode. Frequency tables also give you a way to summarize categorical variables. So whether you are looking at nominal, binary, or ordinal variables, you would organize them into their categories and basically count. And this would really tell you which category represents the highest frequency. So for example, in this data set, most of the members of this sample or population are in the age bracket of 30 to 34. And in the same data set, you can say that there are more males than females. Actually, males outnumber females around 2:1. And this can really give you good insight when if let's say you want to use this data to plan interventions. You know that you are looking at a very young population with a male preponderance, and whatever implication that means for your intervention or for your investigation, you would take that into account. So sometimes we would also want to see how some variables occur in relation to each other. For example, in each of those age categories that we have mentioned, in each of these, we want to know in this age bracket, which of them are male, which of them are female, and so on and so forth. So we would do that here. Within the age categories, we would split them into male and female. We can also do the same thing in reverse. Among the males and females, so these females, what are their distribution by age? How many of them are in this age bracket? How many of them are in the next age bracket? And so on and so forth. And that is where the relative frequency tables come into play. And you would do this in your statistical software by using cross tabulations. So within the sex categories, we can see here, and then we can see here also. And that is when it becomes important for you to really understand what you are looking at in your table to differentiate between row totals and column totals. So these relative frequency tables actually they look similar to what we present as our table ones when we write scientific papers or some other tables, result tables. And in this study where you actually measured, well, this is not very, please disregard this mean hemoglobin. This is age brackets. So here you are just describing the, I think this has not been properly formatted. Apologies for that. Let's just use this. So within the sex categories, these are the age brackets that represent. These are how they are distributed according to age brackets. So it will really tell you how whether in the distribution of your data set you have more younger people within both sexes. It could be that in the male category, let's say you have more people down here in the 50 to 54 years category, and then for females, they are actually mostly 25 to 29 years old. That also would give you a different perspective as to the kind of recommendations or conclusions that you draw from your data. So when you want to present your data as a graph, you should ensure that the graph you are choosing is appropriate and it shows the data that you really intend to show, and then get a second opinion. Label the graph accordingly with good titles and axes to really help the reader to understand what you are showing, and then don't tamper with the axis too much in a way that would really distort the data, like not starting your axis from zero unless you have a very good reason. And in order to also help people to differentiate, for example, between different categories, if you are having, let's say, multiple bar charts or stack bar charts, differentiate them by color. And you should really use the appropriate terminology when you are describing your data. So, yes, go ahead.
Sorry, sir. Just can you explain the phrase using zero except it is absolutely necessary on your axis?
Yes. For example, if you see this number, this histogram, it starts from 0 on this end, and on this end it's starting more like from, it has been cut. The axis has been cut. It's starting from around 17.5 or so. So doing this sometimes might help you to actually fill your data in the window and present it, your graph in the window and present it well in a way that will be visible to the reader. But you should also take care to make sure it is obvious to the reader so that you don't mislead the person. Someone else has their hand up.
Yeah, sorry, I just wanted to highlight that you should also note that the ages, the picture is showing the ages of resident doctors, right? And so it's unlikely for you to have a resident doctor who is 18, 12, or 5. and that's why the x-axis necessarily starts from like 25, which is the minimum age in this case. So that's why it's starting like that. So as you said earlier, I just wanted to highlight for folks, right? Sometimes it's necessary for you to not begin from zero, depending on the nature of the data that you're looking at. But in general, we want to start from zero whenever possible. Thank you.
Thank you, Dr. Abiy. Yeah. So look at if you look at these two graphs, you'd see that on the left here we have a histogram, and this is what we are. This is best for presenting continuous data. It gives us the distribution of the data. It gives us tells us how the observations are gathering themselves and what the measure of central tendency is. But for categorical data, like these categories, if you put it in the software and decide to plot a histogram, it will allow you to do it, but you would not really be looking at sensible a sensible graph, and you'd make wrongful interpretations from the data. And whoever is reading your study would be wondering why you are presenting, why you are saying that the age categories of your resident doctors are normally distributed. If that makes sense. So the categories, we use bar charts, and this would really give you the absolute frequency of each category that you are considering within your data set. So for example, in this data set, this resident doctors data set, the category that has the highest frequency is the 30 to 34 category, which means that most of the residents are 30 to 34 years old. If we remember, we saw this same data also in the form of a table. So sometimes it comes to a matter of preference, whether you want to present the data in form of a table or a graph. So there's something called the bin width. That is this the width of each of these sticks, if you will, and this really would it can change the nature of your histogram. So it can make your histogram more it can change the distribution basically of your histogram. If you look at these two, what you have on the left and what you have on the right, they are both representing the same data, but because you have reduced the bin width here, you can see more observations. So if you have a very large number of observations, you might want to adjust the bin width a bit so that your data is completely visible in the graph. So we mentioned bar charts as a way of using comparisons and the use of colors to help your reader understand what they are looking at. So in this, on the left here, you have a composite bar chart. So here, this is within your, in this stat bar chart, you are calculating, or rather you are depicting it within the age groups. So within the 25 to 29 age group, this is the number of females. If you look at the legend here, this is the proportion rather of females, and this is the proportion of males. And then if you use a side-by-side, which is representation of the bar chart, then you can do a more head-to-head comparison of the of the two categories, that's male versus female. Again, this is also a matter of preference to some extent, and also the number, or should I say the amount of observations that you have and how well it appears when you plot it on the graph. Dr. Abiore, did you have a comment?
No, it
You are
was a
unmuted.
while ago. It's fine. Yeah.
Okay. Sorry, I can't see hands. So on this graph, we can see that a lot of data has been represented, a lot of different categories of data, but the beam widths here are not consistent. The colors, there is no contrast between the colors, so you don't really know what you are looking at. Here you can see is it Indonesia bar is swallowed by another one, and then that one is also swallowed by here. Even for me, I'm finding it a bit difficult to know which one this bar actually, which country this bar represents, and so on and so forth. Here there's a bit of contrast, but it doesn't really make it much better. But comparing that with this, where there is clear contrast between the male and female categories, because of the use of color. One thing to note when you are using color is that some readers might have color blindness. So usually there are color palettes that are friendly to all eyes, basically. And people with color blindness will still be able to differentiate between the various colors on those color palettes. So the R tutors would take you through those. Here again, we have some different types, some other different graphs where you have mannequins representing the bars, and look at the one on the right. I mean, what percentage is this? How do you trace this to actually tell the number, the population of this country? This one has two hands. This one has one hand. What exactly does that mean? So as much as we want to try to beautify our graphs and make them catchy, we should also ensure that in the process of doing that, we are not obscuring the message that we are trying to pass. So here also, this is a graph that is in 3D, and because it is flipped to the left, you might also find it a bit difficult to know which one is taller than which. And then the axes are not labeled. So also this graph doesn't have, you don't know what we are really looking at. Okay, Q1, Q2, Q3, Q4. It doesn't have a title, doesn't have labels. This one is also using a very weird texture for the bars, and then the graph is not labeled. It doesn't have axis labels either. So if you look at the one on the right here, you would see that this information, when you represent it in a more cleaner way, this here you have the writing a bit slanted. Here you have it horizontal, and you are using line breaks. So it makes it easier to read, and it's not cluttering your graph completely. Again, you still need, even though we have ticked this, don't forget your axis labels and your graph titles. And then for this one that is slanted sideways, if you look at presenting it in a 2D format, it's very clear which one has the higher frequency and which one has the lower frequency. So if you look at this graph, this is another example of a bad graph, but it doesn't, it might not be immediately clear why this is a bad graph. Or has anybody got an idea why this is not a good graph?
Yes.
Okay, so
you don't even know you don't know which area represents the data set. Ideally, a good graph should be at most on a white background. So I think the color code should have been changed. If the white zone is what is representing the data points, is the area below the white zone is what is representing the data points, then probably that should have been a different color, and then the rest the background, the rest on the white background.
Okay, that's a good observation. But if you look at this,
upside down, I think.
Exactly, the graph has been turned upside down to miscommunicate facts. So if you look at this, this is the number of murders committed using firearms. That is what you have on your vertical axis. The horizontal axis is your time period. So it's a line graph. And then it is trying to show that at this point in 2005, when Florida enacted the Stand Your Ground law, the gun violence went up. But if you look at it from if you flip the graph and actually look at it the way it's supposed to be, you would realize that the rate actually came down, because this point that has been highlighted is actually closer to 0. But if you display this on a news article, if you look at it, this is from Reuters. So the news organization, their data analysts knew exactly what they were doing. They were trying to push a particular type of narrative, and that is why the graph has been flipped upside down. And there are other tricks like cutting the axis from a particular point and then adjusting the ratios between the ratios of the scale between the y and the x-axis, just until it shows what exactly you want it to show. But these are all not good. That's not a good way to present data. So and then for this one here, we have started the graph from not 0. So I don't know how many more slides we have. Okay, we have maybe just a few more slides. So another way of representing data is using a scatter plot. A scatter plot shows you the correlation between two continuous variables. So correlation just means that what does the second variable do as this first variable changes. For example, on this scatter plot here, you have the GHQ score, which is a mental health score, and the higher the number, the worse the mental health. And on the horizontal axis, you have the workload score. So this is not giving you any form of linear relationship. You can't really draw any line between them. So, and then if you look at the, this is rho, which is the correlation coefficient. It is 0.19, which means it is there's very little correlation. Usually from 0.7, 0.6, 0.7 and above, you would say that they are strongly correlated. But remember, correlation does not mean that one is causing the other. It just means that these things are happening at the same time. So here, if you look at the correlation coefficient, it is completely it is much, much closer to 0, which means that there is zero correlation between the two variables being compared. So the closer you go to 1, the more the correlation, and the closer you go to 0, the less the correlation. You can also have this being a negative value, which means that as one is increasing, the other is decreasing. So when it comes to pie charts, you can see here the maker of the author of the slides has said pie charts are the worst because because of their round shape, it's not very intuitive and easy to tell whether one sector of the pie chart is bigger than the other. It's not immediately clear. And then the more number of categories that you have, the more slices that you have. And then if there are very big categories and then smaller categories, the bigger categories can even obscure the smaller categories and make them almost invisible, which would become problematic as you are showing your data. And then you would also probably run out of colors to use. At that point, you'd again be excluding your colorblind audience. But this is the same data on the left here presented as a bar chart, which is very clear for everyone to see. So a few more examples of graphs not to use. And you can see here, this is even this is a pie chart with several categories. And then because it was not bad enough, this person decided to use a 3D ghost pattern where you can see the internal slices. So there are so many lines and so many colors, it's all over the place and it's difficult to read. Here also can see what it looks like. So that brings us to the end of today's session. I know we have gone a few minutes, about 10 minutes over time. Thank you all for your patience, for staying up till the end of this session. And if there's just one person that wants to tell us what in 1 minute or even 30 seconds, what the key takeaway, what their takeaway is from here, then we'll be happy to hear. And then maybe if Dr. Abiore has some parting words for us, we'll take that as well. Any volunteers? Yep. Go ahead.
Hello.
Yep. Go ahead.
Thank you. Good evening. Can you hear me?
Yes, we can. Yes, we can.
All right. Thank you so much for the lecture. It was very insightful. So the things I took from today's class is one, the different variables that we use, and the different ways we can represent these variables. For the continuous variables, we can use we use the histogram, and then the categorical variables, we can use the the bar charts, which can either be a stacked or a side by side. And I also learned about the things to actually put in mind when you're constructing those charts, like that's the title, the use of clear contrasts, so and labeling the chart as well. And also learned about the different frequency tables, how you can use that to look at the categorical variables to see either nominal or ordinal variables, and also the relative frequency. And yeah, I think and also to avoid the use of pie charts. Yeah, very important. Thank you very much.
Thank you very much. It seems the message was passed very well. I would give the credit to the person who created the slides because I was just here presenting them. So Dr. Obieri, any final words?
No, thank you very much, Mohamed. So we really appreciate you stepping in and helping to take the class. Thank you everyone for joining. I just wanted to quickly qualify the use of the pie chart a little bit and to say that, I don't know if you mentioned it while I was out, that the pie chart, really you should use it when there's only a few categories, so not that you shouldn't use it at all. I think I heard the person who wrapped up the class say that you shouldn't use it at all. No, so you should only use it when you have a few categories. So I mean, it's a useful tool basically. Thank you very much, everyone. And tomorrow at the same time there'll be SPSS session, and next week we'll have R if you have any questions. So I see some people are having concerns about joining Google Classroom. Use email and we'll try to address them. But yeah, if you don't have any other questions for the instructor, we can sign off. Victor, I think Victor has a question.
Okay, Victor.
Good evening. Thank you very much for the lecture. This is directed at Dr. Abiy. He said we can use pie charts when we have a small number of values we're trying to present. So, is there a kind of hard points that we should not go above? So maybe 3 or 4 values, and we should not go above that, or is it just left to the researchers' intuition? Thank you.
Yeah, so here it says 3. So 3 is a good threshold. Thanks, Lisa. Yeah, 3 is a good threshold. Once you start going above 3, then it becomes hard to see the data the way that you want it to be seen, basically. Yeah.
All right, thank you. All right, thank you very much, sir. I'm very
You're
grateful.
welcome. Thank you. All right, everyone. Thank you very much. So we'll see you tomorrow. Thanks, Mohammed. Really appreciate it. All right.
Thank you.
Thank you.
Thanks everyone for joining.
Cheers.
Thank you. Bye.
Bye.